Facilities planning in distribution network design requires the application of total cost integration and systems thinking philosophies. Rather than optimizing individual functions independently, organizations evaluate the combined effects of transportation, inventory carrying, warehousing, labor, administration, and facility costs across the entire supply chain. A systems approach recognizes that decisions in one area influence performance elsewhere. For example, adding distribution centers may reduce transportation costs and improve customer responsiveness, while increasing inventory and facility expenses. Effective facilities planning therefore focuses on minimizing total system cost while maintaining required service levels. This holistic perspective enables organizations to align distribution capabilities with strategic objectives and maximize overall supply chain effectiveness. Business strategy and customer transportation requirements are primary drivers of network design decisions. Organizations pursuing cost leadership often favor centralized networks that maximize economies of scale, while companies emphasizing responsiveness may establish multiple regional distribution centers closer to customers. Customer expectations regarding delivery speed, reliability, order flexibility, and service quality strongly influence transportation modes and facility locations. Strategic trade-offs must balance service performance against operating costs. The number of facilities selected depends on factors such as market coverage requirements, transportation infrastructure, customer density, and product characteristics. By aligning distribution design with strategic goals and customer needs, organizations can improve competitiveness while maintaining efficient resource utilization throughout the supply chain network. Network design must support inventory level objectives by determining where inventory should be stored and how replenishment activities should occur. Inventory placement decisions directly influence customer service levels, transportation efficiency, and overall supply chain costs. Organizations evaluate factors such as demand patterns, forecast accuracy, replenishment lead times, safety stock requirements, and service expectations when determining inventory locations. Decisions regarding order frequency and order size affect inventory carrying costs, transportation utilization, and replenishment responsiveness. Centralized inventory strategies reduce total inventory investment but may increase delivery times, while decentralized inventory placement improves responsiveness at a higher carrying cost. Successful network designs balance these competing objectives to achieve optimal inventory performance and customer satisfaction. Initial network designs often require modification to accommodate practical deployment considerations that arise during implementation. While analytical models may identify theoretically optimal solutions, real-world constraints frequently necessitate adjustments. Key considerations include proximity to customers and suppliers, labor availability and wage rates, tax structures, utility costs, infrastructure quality, environmental regulations, political stability, and access to transportation networks. Organizations must also consider risks associated with natural disasters, geopolitical disruptions, and economic changes. These factors influence both operational efficiency and long-term sustainability. By incorporating deployment considerations into the design process, organizations create more realistic and resilient distribution networks capable of supporting business objectives under changing market conditions. A successful site acquisition process requires systematic evaluation of potential locations at national, regional, and local levels. At the national level, organizations assess economic conditions, regulatory environments, taxation policies, trade agreements, and political stability. Regional analysis focuses on transportation infrastructure, labor markets, customer access, supplier proximity, and economic development opportunities. Local site selection examines land availability, zoning regulations, utility access, community support, environmental requirements, and expansion potential. Each level contributes critical information that influences final location decisions. Thorough evaluation minimizes implementation risks, prevents costly relocation decisions, and ensures facilities can support long-term operational requirements. Effective site acquisition strengthens overall network performance and supports future organizational growth objectives. Distribution professionals use various analytical tools and techniques to design optimal networks of nodes and links. Cost volume analysis helps determine the relationship between operating costs and activity levels, enabling evaluation of alternative facility configurations. The weighted factor rating method provides a structured approach for comparing locations using multiple qualitative and quantitative criteria. Organizations assign weights to critical factors such as transportation access, labor availability, customer proximity, and operating costs, then evaluate alternatives accordingly. These techniques support objective decision-making and improve the quality of network design choices. By combining financial analysis with operational considerations, organizations can develop distribution networks that effectively balance cost, service, and strategic requirements. Advanced network design increasingly relies on optimization, simulation, and heuristic modeling tools to address complex supply chain challenges. Optimization models mathematically identify the best solution based on specified objectives and constraints, such as minimizing total cost or maximizing service levels. Simulation models allow organizations to test network performance under different demand patterns, disruptions, and operating conditions before implementation. Heuristic approaches provide practical solutions to highly complex problems where exact optimization may be computationally difficult or time-consuming. These tools enable organizations to analyze numerous alternatives, quantify trade-offs, evaluate risks, and support strategic decision-making. Their use significantly improves network design accuracy and implementation confidence. Once implemented, network designs must be validated to ensure they perform as expected and continue supporting organizational objectives. Performance evaluation includes measuring customer service, inventory management effectiveness, transportation efficiency, warehouse productivity, asset utilization, and total logistics costs. Continuous monitoring helps identify deviations from expected outcomes and supports corrective action when necessary. Organizations must also differentiate key distribution concepts. Order channels refer to how customers place orders, such as retail stores, websites, or mobile applications. Order fulfillment channels describe how orders are delivered to customers. Distribution networks encompass the physical infrastructure supporting product movement, while fulfillment systems execute customer orders efficiently within that network.